Okay, for our database, we built a website, Academic Matcher, to match computer science art scholars or articles with users who are looking for specialists in specific fields. Because of this, we use the DBLP database to present the right results. And the users of our database could be researchers, students, inventors, or even employees. We primarily used HTML, CSS, and Python in order to code our database, relying heavily on the Flask framework for the backend coding. Our basing functionality includes searching for an author, searching for a paper, finding the authors of a paper, adding an author to the database, and deleting an author from the database. In order to search for an author, you simply search the author's name, and it returns all paper keys that that author is associated with. In order to search for a paper, you give the paper title, and the paper title, the year, it's the conference it was presented at, its paper key, and its conference number are all returned. In order to add an author to the database, you simply go here just to show that this works. Here's our author sorted by RID, and the highest RID is given to the latest included author. So here we now add an author to the database, Zach Rousseau. And once we refresh this page, he's now in the database. Now to delete Zach Rousseau, you simply do that. And Zach Rousseau is no longer in the database. In addition to simply deleting an author from the database, our delete function also checks to make sure that if that author is the last author associated with a specific paper key. If that is the case, that paper key is then removed from the paper database here. And all citations where that paper key is mentioned are also deleted from our citations table. Here. Our two advanced functions include find the most relevant articles and find the most relevant related author. So given an author name, you can simply click search, and our function will then take you through his, and find all authors who have worked on papers with the author provided. Then on that new set of authors, it runs the same search again recursively until we've compiled a list of authors who are greater than 1,000 long. These authors are then weighted depending on various variables, such as how many times they have published a paper, how recently they published a paper, whether or not they've appeared in a conference with our author, and how many times that the papers they have written have been cited before. And at the end, the author with the highest score is selected and returned. And as you can see, in this case, it is Yang Li. In order to find the most relevant articles, you simply provided a topic. In this case, let's go with compilers. Compilers is run, and there are too many results, so we enter another keyword. Let's say x86. x86 is then processed for a while, and then the title of all papers related with x86 compilers is returned with the year they're produced, the year they were written, the conference they're part of, and all authors who associated with that paper. For another example, let's take data. So once again, there are too many results. So let's add systems to our keyword search. Again, so unlike the previous example, even adding systems provided too many results. So we can now specify by what year. So let's say from 2003 to 2005. And now all papers written from 2003 to 2005 related with database and systems are presented here. This function is specified here in our advanced function 1 section, where the paper is selected, the conference name, the conferences are searched for our initial keyword in the details. Let me pull that up. Details here. And then after that, every additional keyword is then drawn from the paper title. And then in the case that we have too many We have if-else statements to direct you to various other functions, such as other keywords, and year question, as well as min citation.